name is Brittany Shamoon, and I am the project manager of the ASSAB engineering team. I also deal with the construction management and geotechnical studies of this project.
My name is Salah Associate, and I'm in charge of the environmental aspects of this project.
My name is Amr Al-Daragma, and I'm in charge of the transportation aspect of the project.
My name is Abdulrahman Al-Hukal, and I'm in charge of the hydrology study and drainage aspect of this project.
My name is Sarah Ashkenani, and I am in charge in the construction scheduling, and I aided in the transportation aspect of the project. In this video, we will be discussing our approaches and findings of the project.
We have been hired to do the SR67 and Highland Valley roundabout. Our design team will address the transportation, stormwater, environmental, and construction aspects of the project. The purpose of this project is to improve traffic flow on the State Route 67 with the design and production of an effective roundabout. An effective roundabout assists and accommodates the flow of vehicles with both safety and efficiency. The SR67 and Highland Valley intersection is planned to be developed into an efficient roundabout. The SR67 and Highland Valley intersection has been dealing with insufficient roadways for years, with high levels of traffic congestion and queue lengths of over 2 miles. State Route 67 is known as a highly dangerous highway due to high numbers of fatalities on the road. This project will focus on providing a roundabout that is accommodating to the flow of traffic both safely and efficiently, with minimal impacts on the surrounding environment and community. The goal of the project is to improve the existing conditions of the road with a roundabout design. This study was done to evaluate the potential geological concerns at the subject site, since it relates to the proposed development and design parameters. Based on the map from the Hydrology Manual of San Diego County, the soil in the area is Class C, meaning that it has a slow infiltration rate. There are no fault zones in close proximity, as well as non-active seismic zones. However, the soil on site is prone to liquefaction, which is why the topsoil and subsurface soil should be removed and compacted again. Earthwork will consist of site preparation, excavation, and compaction. Any compressible material must be removed and oversized rock should be hauled off-site. The soils on-site can be used for compacted fill if they do not contain any debris, organic materials, or oversized rocks. The fill soils should be relatively compacted to at least 90% based on the maximum dry density of the AST test method D1557. An R value of 30 was used for the pavement design based on our experience of the area and the review and evaluation of geological and geotechnical literature. The new pavement structure will consist of a hot mix asphalt surface course and Class 2 base and sub-base. After conducting a geotechnical investigation of the site, the proposed development is feasible based on a geotechnical perspective.
The existing facility consists of SR67, which is a 2-lane rural highway with traffic lanes and shoulders of 12 and 8 feet respectively. A 12-foot left turn lane and a 12-foot right turn lane are present in the north and southbound directions, and it is maintained by the State of California. Highland Valley and Dye Road consist of a 12-foot traffic through lane, one 12-foot left turn lane, and an 8-foot shoulder in both directions, and it is maintained by the County of San Diego. The traffic analysis report analyzes the current traffic and future conditions of the intersection. This is a key intersection but experiences more traffic than nearby intersections. The existing peak hour volumes were analyzed to assist in determining the level of service. The method used to determine the level of service of the intersection was based on average vehicle delay from the Highway Capacity Manual and the principles of highway analysis. The level of service of the intersection is usually E or F, which is undesirable and considered unstable flow of traffic, and it should usually be C or higher. Average daily traffic volumes of the intersection are around 30,000, and the projected future traffic will be around 40,000 by 2040, meaning there will be a 33% increase at least. It is important to consider truck and pedestrian data for design. Truck volumes are typically lower than 10% in the area, and there is minimal pedestrian activity. It is recommended to design a two-lane roundabout to improve the flow of traffic. Intersection volumes were converted into roundabout volumes to determine the number of lanes based on the operational analysis by the National Cooperative Highway Research Program report. The capacity was usually greater than 1,000 passenger cars per hour, so at least two lanes are required, based on the report. The circulatory roadway shall consist of individual lanes of 14 feet, resulting in a total of 28 feet. The central island will be 108 feet, and there will be a truck apron around it. The inscribed circle diameter is 180 feet. SR67 and Highland Valley Die Road both will have two 12-foot lanes in both directions, separated by splitter islands. Since there is minimal pedestrian activity based on the traffic analysis, the design includes a 5-foot bicycle lane that will end near the crosswalk for the pedestrians on the splitter island, so bicyclists can traverse the roundabout like pedestrians. According to the traffic analysis, SR67 experiences extremely more traffic than Highland Valley Die Road, and the through traffic volumes were substantially greater than the right and left turn traffic. The proposed roundabout shall include entry radii that are larger on Highland Valley Die Road than SR67, since the most volumes are through traffic on SR67. To achieve this, the alignment of the roundabout will not be exactly on the intersection to promote the desired curvature for the radii. This design shall allow the traffic on Highland Valley Die Road to decelerate and yield due to the larger entry radii for deflection, so the most traffic volumes, which is through traffic on SR67, can be distributed consistently, resulting in an improved flow of traffic, improved level of service, and reduced congestion.
Ramona City is within the San Dieguito watershed, which is one of the 9 watersheds in San Diego County. The intersection is part of Santa Maria Valley hydrologic area. The natural water paths direct the water flow towards Santa Maria Creek. Based on the hydrology study conducted on the project area, the stormwater runoff drainage system is designed. Prior to designing the roundabout stormwater drainage system, the existing condition was studied. 3 culverts were found in the project area. The 2 on-site culverts will be removed in the proposed modifications applied on the drainage design. The off-site culvert is found to be applicable for the proposed drainage design. The proposed runoff drainage design for the roundabout features 1 pipe installed at the center island of the roundabout. The circulatory roadway will be downgraded with 2% slope, which allows the runoffs to flow toward the curb opening. An open channel will be implemented to carry the runoffs to the pipe. Roundabout legs will not feature culverts. Legs will be graded with 2% slope. To meet the BMP's and LID's requirements, swales will be used to infiltrate stormwater runoffs. Also, a perforated front drain pipe will be implemented. Coarse gravel will cover the surrounding area of the pipe to aid in exfiltrating the stormwater runoff.
The construction scheduling of the project starts with the basic planning for the work breakdown structure and ends with a detailed graphical representation of the sequence of tasks in each sector of SR67 and Highland Valley roundabout. The objective of scheduling is to determine the time and sequence of operations in the project and their assembly to give the project its overall completion time, and hence find the compatibility with the project's cost. With the utilization of a programming tool such as Primavera P6, the procedure of scheduling starts with breaking the tasks into a digestible set of components, establishing task durations based on realistic estimation and application experience, and binding the activities together through specific relationship types to run the critical path method, CPM. The reason behind using CPM method is to manage the time needed for the network activities to be completed and list the critical activities in a mathematical algorithm. This method helped us determine the start and finish dates of each activity. The work breakdown structure contains earthwork, structural items, drainage items, environmental items, traffic items, and other specialty items. Each section contains activities that are internally connected with relationships and externally connected with other sections' activities. For earthwork and structural items, most of the activities have the relationship type of start to start, wood lag, and finish to start relationships. We also use the PERT method in conjunction with CPM to estimate the risk needed for evaluation. Before starting the construction, an encroachment permit is required for conducting the roundabout onto state highway rights-of-way. This way, our construction management plan ensures safety of the traveling public and highway workers, and to protect, maintain, and enhance the quality of the state highway system during and after the permitted work.
The study of the environmental impact report discusses the impacts and issues that might arise from the proposed project. The project includes various environmental concerns that can be potential issues regarding the environment. Mitigation attempts were taken to lower the impacts on the environment before the project initiation. There are 4 different areas that are considered to be affected with the project being accepted. Those areas are biological resources, water quality, noise, and air quality. Biological resources are of most concerns in this project. It is required to mitigate any impacts on the biological resources that include vegetation, plants, or animals. Invasive plants are the most impacted resources in this project. Mitigation plans were carried out for those invasive species by relocating the endangered plants to the roundabout island. Also, we decided to plant a ratio of 3:1 for the other plants that might get affected. The water quality is also an important concern for this project. There are several wells around the area of the project that can be affected while constructing the roundabout. Therefore, all existing wells that might be affected by blasting and constructing will be covered during the construction phase. Noise is also an important factor to be considered in this project. Noise will be mitigated by not exceeding the sound level of 75 decibels while constructing the roundabout between the time of 7 a.m. to 7 p.m. Air quality is also a crucial factor to be taken into consideration. While constructing the roundabout, the standards for the federal and state criteria pollutants will be followed. Moreover, post-construction of the roundabout will greatly improve the flow of traffic and will avoid cold start mode for vehicles. Thus, the emissions from the roundabout will decrease. Overall, those impacts on the environment were determined to be insignificant.
The SR67 and Highland Valley roundabout project was found to be applicable to the intersection. The roundabout improves the level of service and lessens the queuing in the area. Our roundabout design will safely and efficiently improve traffic flow and reduce congestion.